Hello, I'm Radhika and I'm going to introduce our work Task-Agnostic and Post-hoc Unseen Distribution Detection. This is a joint work with Seongjun, Professor Sharon and Professor Edward Choi. Motivation. Deep neural networks have achieved phenomenal performance on diverse applications like object detection. However, they often struggle to handle unseen samples, leading to unreliable predictions. To this end, out-of-distribution detection task is proposed, which aims to detect samples from unseen distribution. Prior work evaluate on OOD samples which have little relationship with ID samples. However, such an evaluation can be unrealistic. In real world, unseen samples are often generated due to the shift in ID dataset by some specific attributes. Such samples are called as natural attribute-based shifted samples, and the task of detecting them as NAS detection. Detection of such samples is more challenging since they share features with ID samples. Prior work mainly focus on classification tasks and are not directly applicable to other tasks. Although few techniques estimate uncertainty in regression, they are not post-hoc. This raises an underexplored question: can we design a task-agnostic and post-hoc approach for unseen distribution detection across diverse tasks? Methodology. To this end, we propose a task-agnostic and post-hoc unseen distribution detection method TAPUDD, which comprises of two modules, TAP-Mahalanobis and Ensembling. TAP-Mahalanobis. The features of the training data are given as input to this module, which first partitions them into K clusters. Then it models the features in each cluster independently as multivariate Gaussian and compute empirical cluster mean and covariance. At test time, TAP-Mahalanobis module takes the given sample and compute the negative of minimum Mahalanobis distance from the clusters. This score is then used to detect unseen samples. However, it is not straightforward to determine the optimal value of K. To this end, we present an ensembling module. In this module, we obtain the TAP-Mahalanobis scores for multiple values of K and aggregate them to obtain ensemble score, which is then used for detecting unseen samples. Results. We present the AUROC score for NAS detection in binary classification task. The highlighted row here presents the performance on in-distribution data. TAP-MOS is a task-agnostic and post-hoc extension of MOS that we presented as an additional baseline. Our approach significantly outperforms all the baselines and is comparable to Mahalanobis. NAS detection results for regression task. We observe that our approach outperforms the baselines. OOD detection in large-scale classification. Since the shift in OOD detection datasets increase in a continuous manner, it is non-trivial to determine for which OOD datasets the score should be high. To this end, we perform an analysis and observe that textures is visually different from ImageNet and hence it is more OOD. Further, we apply PCA on the feature representations to visualize the location of samples and observe that most of the samples from textures are located away from that of ImageNet, thus indicating that textures is more OOD. We further conduct a quantitative evaluation and observe that textures is more OOD, which aligns with our analysis from previous slide. Conclusion. We propose a novel task-agnostic and post-hoc approach to detect unseen samples and empirically showed that it can be used for multiple tasks. Please refer to our paper for more details. Thank you.